Question here 24 is which one of the following is not a resonance structure of thiocyanate? Now, simply think that you should look over here, think in terms of Lewis dot structure and look for carbon valency where it is not 4. For structure 1, we see 4 carbon bonds. Okay, so this is correct. For B option also 4 carbon bonds. For C also 4 carbon bonds. But if you see the D option, here we are having 3 carbon bonds and hence our answer over here is going to be D. This is not the correct resonance structure of thiocyanate. Instead of doing the formal charge calculation, just try to do this in an exam. It will be easier. Which one of the following is a inner orbital complex that shows diamagnetism? Okay. Now over here, ammonia is a weak field ligand. Okay, it is a weak field ligand. But in the complex of cobalt, where it says cobalt is +3, always remember when cobalt is +3, for all the ligands except fluorine, it is going to be diamagnetic. This should be committed in mind. Okay. So in this question, instead of doing the VBT for all the structures, just remember for cobalt 3, okay, for all ligands except fluoride, it is low spin and diamagnetic. That is all you have to remember. Okay. Next question given over. So answer over here is D. 26. Which one of the following is an example of a neutral bidentate ligand? So just draw the structures and you will get the answer. For oxalato, this is the structure of oxalato. So we can see it is a bidentate ligand, but it is dianic. For phenanthrolene, we can see this is the structure. Okay, over here. And the N atoms are present over here. So this is a neutral bidentate ligand for glycinato, and hence our answer over here should be this one. Let's draw the structure of glycinato. It is something like that. So it is bidentate but monoanionic, and nitrilotriacetate means this one. Okay, it is basically this. Okay, so this is the nitrilotriacetate. So it is a basically tridentate ligand. Okay, or rather it should be said as a quadridentate ligand. Next option over here is which one of the following is the correct IUPAC name? So we never use tri, bi or penta, tetra for the cation. Okay, so over here it should begin with potassium first of all. Then for the complex we have to mention the ligand name first. So for nitrosyl and cyano, C comes first, it should be cyano. So potassium pentacyano nitrosyl, and since the iron is present within the anionic complex, it should be ferrate. Okay, so the correct option should be over here, C. Next is given to us the number of geometrical isomers that can exist for the square planar complex. So it is basically M, A, B, C, D type of a complex. So let's look at the arrangements that one can make. Instead of writing the ligands, just use A, B, C, D for fast calculation. So keep the position of A fixed, B, C, and D. So that is the first one. Next one will be switch the positions of B with C. So this is one more, and the other one, think of switching the positions of B and D. So in other words, if you think this way, change the ligand, that is trans to A. So C was trans to A, B is trans to A, D is trans to A. So obviously there should be three such possibilities. Over here it is given which of the following types of isomerism are exhibited by this complex. So this is basically over here again MB4A2C type of complex, where A and C both are monoanionic. Sorry, let's try it again. Monoanionic ligand. So if they exchange between each other, we can say MB4ACA. Okay, this type of complex can be formed. So this is basically showing what? Ionization isomerism. Alright. Now over here NO2 is ambidentate. So obviously one more isomerism possible is linkage. Okay, so that should be possible. In other case, what we have in complexes of the type MB4A2, we can say the geometrical also is possible. For this one, we will say geometrical is possible. So what are possible? For this one, we said linkage is possible. If the arrangement is like this, then it is showing ionization, isomerism. So we will be looking for these three options in the three things in the option. So what we can see over here, linkage, ionization, geometrical. So this is the option. The option B is the correct option over here.